behalf of PP International School, I would like to welcome you. We are delighted to have you with us today. We are keenly looking forward to interact with you, ma'am, and I hope that this session would be fruitful for our lovely students. Thank you, ma'am. Now you can begin.
Thank you so much, dear Pooja. Let me try to share my presentation. I have a short presentation, hopefully no more than 20 minutes. And I wanted to talk to you about my journey and how I got to work for NASA in some of the fabulous work that we do at NASA. With that, I'm going to leave some time at the end for some of the questions that your teacher sent me, and hopefully, I can answer most of them with the time that we have. So I wanted to start with why I ended up working at NASA, and that was because I was able to watch the first moon landing. This is Apollo 11 in July 20th, 1969. At that time, I was only 7 years old. And I know you guys are, middle school, elementary school, but it's never too early to start dreaming about what you want to do when you grow up. And for me, it all began with Apollo 11. And it was just such a wonderful thing to see the first two men walking on the moon, Buzz Aldrin and Neil Armstrong. And so one of the things I wanted to tell you about myself, you probably hear that I also have an accent like you do when you speak English, when I speak English. And it's because I was not born in the United States. I was born in Costa Rica, which is a small little country in Central America. I did not know what NASA was. I didn't know that I was ever going to be able to come to the United States and do the work that I do. But I knew that there were men walking on the moon, and that was what really propelled me to study physics and engineering, which is what I ended up studying. So I did go to elementary school in Costa Rica. This is my picture. If you can see that's me there. And then I went to high school in Costa Rica as well, and that's me there. And the time I was in high school, I actually had to go and work and to help my family because my mother was a single mother. I did not have a father. My father never recognized me, so I grew up with just my mom. And my mom ended up getting really sick and in the hospital for many weeks. And we lost everything. We lost the house. We lost everything. So I had to work at a very early age. But that didn't stop me from going to high school. I went to high school and I did really well. I only had so much time during the day, to go to school, to work, and to do the chores around the house too. And so whenever I got a homework, I learned to do the homework with the intent of learning the material when I was doing my homework, not just to get it out of the way. And so by the time tests came, I already knew the material. I didn't have to kill myself the day before the test just to do well because I knew what I was doing. So of course I went to the university, and those days there were not many women in engineering in Costa Rica, especially electrical engineering, which is what I wanted to study. They did not let me study electrical engineering because I was a woman. So I started in industrial engineering. I spent 3.5 years in industrial engineering, and I still didn't like it. I wanted electrical. So I decided to take my luck and come to the United States. And I never looked back. I came and I didn't speak English. It was, I only had the English that I had learned in high school, which wasn't much. You guys speak English. I could not even, spell some things when I came. But I came, found a job, and really tried to find a school that I can go to. Took the test of English as a second language. I barely passed it with 1 point, but I made it. And I ended up going to school. And 3.5 years later, I was able to graduate with a degree in physics and electrical engineering, which is what I always wanted. It took me a long time I took the 7-year plan to finally make it through college, but I wanted, when you want something really bad, you fight for it, and you go and do anything that is important to you to achieve your dream, and that's what I did. So I graduated from college, and I went to a job fair. And in that job fair, I was lucky that by then I knew what NASA was. I knew that I really wanted to work for NASA somehow, and I was going to make it. And I was lucky enough that I got hired by a company at first. It was a contracting company that supported the NASA work. And then 3 years later, I was hired by NASA directly. So I have been working for the agency for 30 years, plus the 3 years that I worked as a contractor prior to that. So in that career, I have touched all of the science aspects that NASA does. And I know all the videos that were running before I started the talk. About the human exploration and all the scientific things that we do and everything. So NASA is big, it's huge, not just in the sense of human exploration, but also what we do scientifically. And my career has always taken me to do more to the science and the unmanned mission side of the house. So I have worked with astronauts. When I was servicing the first servicing mission for the Hubble Space Telescope, which was done with the shuttle. I also worked with astronauts when we were deploying the Upper Atmosphere Research Satellite, but I was focused in building the satellite. I have touched astrophysics, heliophysics, planetary. I worked on a Mars mission, Mars atmosphere and volatile evolution. And of course, Earth science, Earth missions observing our planet. Today, I am the Deputy Director for the Earth Science Division, overseeing everything that NASA does related to Earth science and taking care of our planet. So this is NASA. In case you did not know, NASA has 10 centers across the United States. I was based for the better part of my career at the Goddard Space Flight Center, which is in Maryland, up here. So today I am based at NASA headquarters. But as you can see, NASA is huge, and the only 2 centers at NASA that do complete unmanned missions are Goddard and JPL. This is Johnson Space Flight Center, where the astronauts train and they have the mission control for the International Space Station. Then we have the Kennedy, of course, where we launch our missions. Goddard actually also has a launch launch camp in Wallops Flight Facility. And at Marshall, we build rockets. And then at Ames, it's just a research, such as Glenn and Langley. And Stennis also builds rockets. And talk to you about the science aspect and what we do. And I'm going to show you what we do to build a satellite. So we take care of protecting and improve life on Earth, which is my job as the Deputy Director for the Earth Science Division. Of course, we search for life elsewhere because we want to know if we're alone or not, in this big universe. And of course, discover all the secrets of the universe as we move forward. These are all of the unmanned missions. That means satellites that are orbiting the sun, or looking at the universe, or we have gone to every planet in the solar system. And of course, we have a large number of missions orbiting our planet, trying to understand Earth as a system. These are again the Earth science missions. These are the missions that I am responsible for. We manage a budget, annual budget of $2 billion annually. We oversee 22 missions in operations. We are building 16 more. And that does not include all of the CubeSats missions that we are also doing, technology, applied sciences, research, and all of the wonderful work that we do to help understand our planet. So I'm going to talk.
Excuse me, ma'am. Can I ask you a question? Have you ever been to space?
I have never been to space. I wanted to go to space when I was a lot younger. So I'm going to talk to you a little bit about how to make a satellite based on the mission to Mars that I worked on. I have a lot of videos on that one, and so I wanted to share some of them with you. But a satellite is just a mechanical structure with solar panels, an antenna, and instruments, which are the main component and the most important thing. And in this case, we wanted to go to Mars to understand why Mars lost its atmosphere. So we wanted to understand the impact of the sun on the Mars atmosphere. And so we mounted some instruments that talk about that could detect, get some data. We wanted to understand what was happening right there in the atmosphere of Mars. And so we mounted some instruments that could measure the ionic properties and processes occurring right there on the surface in the atmosphere. And of course, we wanted to understand the atmospheric composition, chemical composition. So we mounted an spectrometer and mass spectrometer, a couple of UV spectrometer and a mass spectrometer to understand that. See, building satellites is a really complex thing.
Ma'am?
Yes?
Ma'am, do you make the satellites, ma'am, fireproof?
That's my job. Yes, that's what I have worked on, is building satellites. Yes, and it's very hard to make. You have to, like those little videos show you, is there are complex little things that take a lot of time to build. This satellite took 5 years to build. This is the Maven satellite that went to Mars. It is still orbiting Mars. Yeah.
Ma'am, so the rockets can sustain my meteors.
Save a video of a rocket in them. Yeah.
Okay, ma'am.
Yeah. So this is one of the last things that we do. It is deploying the solar panels, because it's very important to charge the batteries. And we launch the satellite like this with the panels tucked in. And then once it's done, then we give it to the rocket. The rocket team is a complete separate team. The satellite team is a separate team than the rocket team. We have to work together because we have to interface the satellite with the rocket. But then once we finish it, we give it to them, and they enclose it into the fairing, and then they take it to the launch pad. And here you see how they lift the cone up to the top of the rocket. And we, the people who build the satellites, cannot talk to the satellites, cannot touch them anymore. We can only detect their life signs through the rocket umbilicals, and know that the battery is getting charged and that everything electrically is working. Pay attention to this launch. And this is one where we recovered the booster. So it's a really cool video. The satellite being deployed from the rocket. So anyways, so that was those are some of the videos I wanted to show you. As I don't know if somebody had a question. I could barely hear with the noise. Do you want to leave the questions for the end? And I'll be done in a few minutes, and then we can take all the questions at the end. Is that okay? Okay. So this is what we do, what we study Earth, and we have to make sure that we understand our planet as a system. So all of these satellites that we manage, that we have, in the cooperation that we have with other countries in the world, are to understand our planet. And we do have a cooperation with ISRO, and we are building the synthetic aperture radar satellite with ISRO. And in fact, some of your countrymen and women have been at JPL, where we are building this satellite called NISAR. And so we're very proud of our partnership with India and with ISRO, building the first synthetic aperture radar mission that we are going to launch together. But it's in order to understand, our planet, and understand what we are doing, and make sure that we understand the interactions with the world. The ice, the water, the clouds, the volcanoes, the ground, everything is tied together, because Earth is an interrelated system. And we study with these satellites all of these aspects, atmospheric composition. I apologize about the Spanish. That's my native language. and I forgot to change that. We studied the carbon cycle, the climate change, the surface of the earth, the interior of the earth, the water and energy cycle, the atmospheric dynamics. So we do a lot. And when we talk about climate change, we definitely can measure the effects, can understand that there is climate change, and there is two satellites that contribute to the data that measures the sea level rise, and one of them is Grace, and the other one is Jason 3. So Jason can measure the height of the ocean, and Grace can measure how water moves around the globe. And there are the biggest indicator that there is climate change is the sea level rise. And right now the trend is about 3 millimeters per year. So and it's exponentially increasing. Also, we can measure the temperature of the Earth. Of course, in 1880, we didn't have satellites to measure the Earth, but we did have temperature thermometers, and we could actually take the data from the thermometers on those days and put them in a model and combine that with satellite data. And it's given us a view of how the Earth has been warming through the years since the 1800s. When we combine this with the sea level rise, we know that the oceans are heating up. So the index of thermal expansion combined with the melting of the polar caps, which we can see here, are contributing significant to the changes that we're experiencing. This is the Arctic sea level. Of course, in the winter it freezes, and the summer it melts, and back and forth. But every winter it freezes less and less, and we have lost a lot, millions of kilometers of Arctic sea ice in here. As you can see, by I think the 2019 is the last day that I have in here. Is it is really going down. And here is the fleet of satellites that we have currently orbiting our planet.
But satellites also have the GPS.
There are satellites that have GPS. Yeah, some of them do
They
now.
track waves from space, and then we get it on a GPS.
Yeah, they didn't used to, but
Ma'am,
now,
do you still make
now
rockets? Ma'am, do you still make space shuttles?
that we don't have the space shuttle anymore. That retired a long time ago. So I wanted to leave you with a couple of pieces of advice. First is to follow your dreams and do something that you're really passionate about. Remember that I told you at the beginning that I was 7 years old when I wanted to go to the moon. I wanted to work for NASA, and I was able to do that, even though I was not even born in the United States. And I was able to follow my dreams and really do everything that I had to do to make my dream come true. Don't listen to the perception of judgment of others. Sometimes people are going to tell you that you cannot do this or you cannot do that. They told me many times that I couldn't be an engineer because I was a woman, but here I am, an engineer, and I build satellites, and I'm very proud of it. Always seek mentors and have more than one mentor at a time. It's very important that you have mentors. But eventually, I want you to think about being a mentor too. It doesn't matter how young you are. If you are an older student, take on a younger student and mentor them and help them. It's very important that you do that. Also contribute to increasing the girl pipeline. We girls are very smart, and we can do anything that we want to do. So just help each other, and always give thanks to everybody who can help you. Your teachers, your parents, always be grateful for everything that you have. And also remember that many people are going to be willing to invest in you to help you accomplish your dreams and your goals, but only if you are willing to put forth the effort that you need and demonstrate that you are committed to the goals. Otherwise, if you don't care, nobody cares. But if you care, a lot of people are going to be there for you. So with that, I'm going to end my presentation, and I'm going to take all of the questions that you may want to ask me.
Ma'am,
Mm-hmm.
ma'am, how many satellites you have made till now?
I have worked on 8 satellites.
Ma'am,
Raise
All the
your hands. I
students
don't
are
know.
requested
There's a
to
hand.
type
Yeah.
their questions in the chat box, please. All the students are requested to type their questions in the chat box because we are going to begin with question answer round, and then some students are going to ask questions on behalf of you all. So please don't unmute. Yes, ma'am, please go ahead.
Okay. Okay. Did you do? Oh, are there real aliens? No, I haven't seen any. I don't know about aliens yet. Um, okay. What are the names of the satellites that I have worked on? So I have worked on um, the Upper Atmosphere Research Satellite, the EUV Extreme Ultraviolet Explorer, Hubble Space Telescope. I have worked on many versions of the Geostationary Operational Environmental Satellite. I have worked on the Gravity and Extreme Magnetism SMEC satellite. I have worked on the Mars Atmosphere and Volatile Evolution satellite. And it is just a lot. And on the GOES, the Geostationary Operational Environmental Satellites, I worked on GOES I through M and N through P and GOES R. But I worked on the satellites, but I was able only to work on 3 of the launches.
All
And
right,
that's
thank you,
about it.
ma'am.
Let me see what else is here. I'm just trying
So,
to scroll and see the questions. Yeah.
okay, ma'am. So, all
Um,
right, now we are beginning with the question answer round. So, Alina, please go ahead and ask the questions.
yeah.
Yeah.
Ma'am, what are the criteria to get in NASA?
Oh, the criteria to get in NASA. Well, so NASA is what we call a federal agency of the government of the United States. So to work for the government of the United States, you have to be a U.S. citizen. You have to be either by birth or by becoming a citizen. You can have been born someplace else, but you have to be able to be a citizen. To work as a contractor, you can be a resident. You don't have to be a citizen, but you have to at least have a residency in the United States. We hired any engineering, physics, math. We hired lawyers. We hired doctors. We hired all careers. So anything that you want to be, you can do at NASA. Is
Ma'am, so my
Good
question
morning, ma'am.
is, how
Good morning. Mhm.
how do astronauts get ready to fly in space, and who chooses those people who go there?
So, so before each mission, astronauts train for the job that they're going to do in space. So when I helped the astronauts with the first servicing mission for Hubble, I had to help them train. So they spend many hours learning information in a classroom, as well as handling all the space equipment. And of course, a key difference between being on Earth and being in space is the sensation of weightlessness that astronauts feel. So as they prepare for these jobs, they have to get in a pool and mimic the buoyancy, the weightlessness, and they have to train with the big space suits. So they train for the spacewalks in a huge water tank. That's like what they do. They also wear a modified spacesuit, and the working conditions don't give the true weightlessness, but it's the next best thing that they can do. So it requires a lot of training and a lot of
Ma'am, my question is, what are the impacts of this dynamic space system on humanity?
the impact of. Can you
Dynamic
repeat?
space system on humanity.
The dynamic space system on humanity. Well, so we are very lucky because our planet is protected by the magnetosphere. That is a big magnetic system that surrounds our planet. So the space out there is very dynamic. There is a lot of radiation, and the sun is constantly spewing a lot of material, plasma, radiation towards our planet. but our planet is completely surrounded by this magnetic field that protects us from all of that. So we do get some ultraviolet radiation. That's why we get sunburn when we are in the sun, and of course we feel the heat because that comes through. But the radiation is big, and as soon as the astronauts get out a little bit out into like the space station, they have to be protected. If there is a coronal mass ejection that is coming towards Earth, they have to get in a special compartment that protects them, because they are not as protected up there as we are here down on the surface of the Earth. And if we are ever going to Mars, one of the dangers that the astronauts will face is extreme radiation, because they are going to be exposed to space.
In which year did you join?
Oh, okay. I joined NASA in 1991, February.
Ma'am, how many planets you have gone?
I haven't gone to any planets, only Earth. That's my planet. Yeah.
Okay, now next question, Pradesh, please go ahead.
Ma'am, the question is that what caused the Big Bang explosion to happen?
Okay, so the Big Bang was like no explosion that you might witness today. For example, I mean, if you go and do a hydrogen bomb explosion and or something of the sort, it wasn't like that. So for the way that the scientists describe it is, it started with a very small speck of energy jamming to a very tiny little point, and this extremely dense point exploded with an unimaginable force, something so big, and it created matter and propelled it outward in billions, and that created the galaxies and everything that we have today. But according to the Big Bang theory, started with a very tiny little speck of energy in a very, very tiny point, and that exploded and caused the Big Bang. I actually worked with the scientists who discovered the Big Bang, who had the theory of the Big Bang, and he's just an amazing man. He actually worked on a mission called Kobe, and that mission gave him all the data that he needed to actually understand that the universe is expanding, and that we had the Big Bang.
Do you know
Students, one by one, please.
what do you know about Pluto?
She's asking, what do you know about Pluto?
Oh, Pluto. Sorry, yes. Pluto got downgraded from being a planet, and I think it's been upgraded again. That's the last I hear that because it's such a far away body, and it can be an asteroid or it can be a planet. It also has a very funky orbit, So the judge is
Very good, lovely. Now, Janvi, you can go ahead with your question.
Yes, ma'am.
Yeah.
Good morning, ma'am. I hope you're doing better now. So the question which I wanted to ask you is that what would have happened if Earth was near the center in Milky Way galaxy?
Okay, so I have to say that Earth is in a nice, quiet place of the galaxy. As you get more into the center of the galaxy, there are a lot more stars, a lot more planets, galaxies. Everything is closer to the center. So when we see images of our Milky Way, we're seeing towards the center of the galaxy. We are actually on the outside. So towards the center, there is a lot more radiation. So if you live if you live closer to the center, the biggest concern will be a close encounter with a supernova. Supernovas occurred a lot in the center of our galaxy. We will also be exposed to a lot more radiation, another of the big hazard that lies within the Milky Way center is a supermassive black hole called Sagittarius A. And if you get sucked into the black hole, it's not going to be pretty for anybody. So I like it that we are really at the edge of our galaxy and keeping away from all the radiation, the black holes and the supernovas and everything. So the most dangerous place for a planet is actually in the center of our galaxy, any galaxy.
Can I say a question?
Yes, Jaish.
Ma'am, have you ever worked on a satellite that goes to sun?
I didn't get that. I'm sorry.
Have you ever worked on a satellite that goes to sun?
Yes, actually, we launched one. It's called the Solar Parker Probe, and it's the satellite that has gotten the closer to our sun. Yeah.
Question is, how do astronauts get ready to fly in space?
Well, like I said before, they have to train for many hours, and for this mission, they have to train for the job that they are going to do in the space. So they spend a lot of hours in the classroom, also in a pool of water, testing the equipment, learning how to use the suits. So it is really intense, and it takes years for them to learn. Not just to become an astronaut, because that takes a long time. It's almost like a 4-year process for an astronaut to become an astronaut. But every mission requires them to really train intensively to be able to do the mission.
On behalf of every student of PP International School, we would like to express our appreciation for your inspiring presentation, backed by years of depth of research, years of insight, knowledge of the subject, and its presentation in such an interesting way that it will surely work as a source of motivation to our generation.
It's been a pleasure.
Thank
Thank
you
you so much for having me, and thank you for inviting me to talk to all of you today.
For one of the most memorable webinars of our lives. It will be a great pleasure and a matter of pride to be associated with you. Our best wishes for all your future ventures.
Thank you so much. Thank you for having me.